Question number 2.211. An ice which is initially under standard condition was compressed up to a pressure P equals to 640 atmospheric pressure. Assuming the lowering the melting temperature to be linear function of pressure under the given condition, find what fraction of ice is melted and the specific volume of water is less than that of ice by delta V dash is equals to 0.09 centimeter square per gram. Okay, so it means initially there is some ice which is compressed by this much amount of pressure. Okay, and we are trying to reduce the melting point of ice, which is linear function under this given condition, and the fractional volume change is 0.09 centimeter square per gram. Okay. So first we need to check the change in temperature due to this pressure change. For that we can use Clausius equation, that is dT over dP. This one is Clausius equation. Okay, dt over dP is equals to T into V2 dash minus V1 dash over latent heat of melting. Okay, this is latent heat of melting. So from here we can write that delta T, change in temperature, okay, which we are trying to lower down the melting point. This is lowering melting point. How, by which magnitude we are lowering it down, delta T is equals to T into delta V dash into delta P over L. So let's note down this equation. Okay, now see, when we are supplying some heat, okay, so that heat released by the ice, Q would be equals to M C and delta T, and this much amount of heat will be utilized in melting, let's take m kg of ice, m dash into L. So from here we need to check out the fraction, that by which fraction this melting is taking place. So basically our objective is to calculate melted mass divided by original mass of ice. So here we can write this is L over C into delta T. Right. Now we already have a value of delta T which can be substituted here. So if we'll substitute in this expression delta T from equation number 1, then we'll get L over C into T into delta V dash into delta P divided by L. Okay. So our this change would be M dash over M is equals to L square upon C into T into delta V into. Okay. Now see, we have all available values which we can substitute, like C is 4185, okay, that is joule per kg Kelvin. This is amount of C for water. T temperature is given, standard temperature, that is 273 Kelvin. Delta V is given here 0.09. We can convert it in standard form. Okay. That is 10 to power minus 4 per gram. Okay, so gram can be converted in kg. So this is meter cube per kg. Okay, this should be centimeter cube, not centimeter square. Okay, now see, this is delta V. Our temperature is known, pressure is known, 640 atmospheric pressure, L is 333. So if we'll substitute all these numeric values and calculate this ratio, then we'll get 0.03. It means if we compress the ice and lower its melting point, then in this process, this much fraction will get melted.